talking about finding solution of partial differential equation. So I was telling you what is a partial differential equation. Then I was telling you how to solve like I was telling you, like if you have z is equal to ax plus by plus ab. This is an given equation where z is a function of x comma y. I was teaching you how to eliminate this a and b, how to bring this partial differential terms inside. So in that I was telling you small p. What is small p? Dou z by dou x, and I was telling you small q is dou z by dou y. So p is dou z by dou x and q is dou z by dou y. So we were working on this. We differentiated this with respect to x and with respect to y partially, and after doing those two differentiations, we applied the answers so that we got partial answers. Am I right? Partial differential equations. Now we are going to the next level. So here I have some ideas for you. So in the ordinary differential equations, while solving differential equation, I think you remember, suppose if you have like this d square plus 5d plus 4 of y is equal to sin x or cos x or x square or 0. This is an ordinary differential equation, I think you all know. We are solving this by finding two concepts. One is called complementary function. The other one is particular integral. You should have studied in the previous semester. The other one is particular integral. So adding these two, we will get the general solution, final solution. Adding these two, we will get the general solution. This was the idea to solve the given differential equation. Partial differential equation can also be solved in this manner. So in order to variate ordinary differential equation with partial differential equation, the equation model will be variated. Like for example, instead of d, you will be given d dash, d power dash. So if I give d dash like this and like this, so there is a variation of d dash. So whenever you come across d dash, we are working with partial differential equations. In order to change the notation, they are using these ideas. Okay, so we will in our plans we have to think how what. So I think for complementary function there are various scenarios. I think you all remember. We will factorize the given expression and we will find the roots. If the roots are equal, we will go with one complementary function idea. If roots are different, we will have another idea. And the third one is if the roots are complex roots. If the roots are complex roots, we will have a different complementary function idea. Am I right? So, according to the roots after factorization, we will understand the right methodology, right CF formula, we will apply, we will get a solution. And again, if some right hand side is there, apart from 0, there is some right hand side, we will find particular integral also. There are various types of particular integrals based on the right hand side. So based on this f of x, so what is given, whether it is e power ax model or whether it is exponential, whether it is logarithmic log x square like that, or whether it is trigonometric, or algebraic x square x cube x power 4 like that. So according to the right hand side, according to the homogeneous concept available there, we will be working on the proper particular integral idea. Okay. So in the same way, in partial differential equations also we have a list of formulas for complementary function and also for the particular integral. So in that way, so for to find complementary function, we have various ideas. For example, if the roots are distant, subdivision 1, type 1, if roots are same kind of idea, you are having a differential equation, you are factorizing the left hand side of the differential equation and you get some roots. If the roots are distant, what do you mean by distant? Two different roots. We have a certain idea. So similarly, for equal roots, when the roots are equal and like kind. So when the roots are different, what is the methodology, what is the CF formula, when the roots are same, what is the idea. Am I right? This is how we have